So first of all, what is global warming?
Well, humans are putting carbon dioxide into the atmosphere, primarily as a result of the burning of fossil fuel, coal, oil, and natural gas. And those and the carbon dioxide that is emitted absorbs the heat that is re-radiated to space by the Earth. And that causes the atmosphere to warm up, and the land and the oceans to warm up, and that's basically global warming. As long as we continue to burn fossil fuels, the amount of carbon dioxide in the atmosphere is going to continue to increase, and the atmosphere will continue to absorb more heat, and the Earth will get warmer.
So what are the main causes and effects of global warming?
Well, the main cause is the use of fossil fuel, the burning of fossil fuel. That's responsible for about 80% of the carbon dioxide that's emitted into the atmosphere by humans. Deforestation is also a cause, and some agricultural practices like raising cattle, because cattle lead to the emission of methane. Methane is another gas that traps heat in the atmosphere. So those are the main causes. And you asked about the effects, or? Well, the main effect is that temperature increases. That's what's most notable. And we've seen temperature increase steadily over the last 50 or so years. So the last year was the warmest on record, and I think 9 of the 10 warmest years on record were in the last 10 years. But that warming has other effects. So the main one to be worried about is changes in precipitation. So as the Earth gets warmer, some places will get drier because you'll have more evaporation. Other places will get wetter because that evaporated water will come down someplace. So rainfall patterns are changing around the world. We're also seeing more storms, more heavy precipitation events, more downpours, more snowstorms. We just saw this the last few weeks in New England, and it may seem paradoxical that snowstorms are associated with climate change, but as the ocean gets warmer, there's more evaporation from the ocean. And so that water is evaporated, it has to come down someplace, and in the case of New England, it's been coming down as snowfall. Another effect from carbon dioxide being emitted into the atmosphere is that carbon dioxide is absorbed into the ocean, and it makes the ocean more acidic. That is of concern because coral reefs don't like acid. In fact, it can dissolve the coral in the coral reefs, and we're seeing the bleaching, basically the death of coral reefs due to the increased acidity of oceans. So those are some of the major effects. Another major effect is sea level rise, that as the atmosphere gets warmer, as the ocean gets warmer, ice melts. We're not concerned so much with the ice that's floating in the Arctic, but the ice on land, like on Greenland and glaciers, ice in Antarctica. Because that ice is on land, it's not floating. When it melts, the level of the ocean rises. And this ocean also rises, sea level also rises, because as water gets warmer, it gets less dense. It occupies more space, more volume. And so just the heating of the ocean, even apart from the melting of ice, increases sea level. And we have seen sea level increasing significantly. And in fact, if we continue on the same path, sea level could increase by as much as 3 feet over the next century, which would threaten many cities, many towns that are near the ocean.
So, based on what is happening as of now, in terms of weather and sea level rise, where do you think we would be in 20 years?
Well, 20 years is, in this scale, not so very long from now. Climate is changing gradually and slowly, and there's a lot of variation from year to year just based on, well, things that have nothing to do with global warming, depending on whether there's an El Nino event or the weather in any particular part of the world depends on a number of random factors. But I think we can say the Earth will be a bit warmer and a bit stormier, and mostly though, when people talk about climate, they talk about changes over long periods of time, average changes over, say, 20 years. And so exactly how much temperature will rise or how much sea level will increase is hard to say. People have been focusing mostly on projecting what the changes would be over 50 or 100 years. And over that time frame, the changes are very significant. Of course, they depend on if we continue to burn fossil fuels at the same rate we're doing now or at even greater rate, or if we begin to decrease our burning of fossil fuel. That's really what the long-term future depends on.
So, how would you suggest that we decrease our level of use of fossil fuels?
Well, we have many alternatives. Well, I should say the first thing is to use energy more efficiently. And in the United States, there is a lot of room for improvement, particularly in buildings. Our use of energy for heating and cooling buildings. Buildings could be, in particular, better insulated, as well as in cars. The most fuel-efficient cars are about twice as efficient as the average car. And usually this is the cheapest way to reduce energy use, is through efficiency. In fact, sometimes, and quite often, it doesn't cost any money to be more efficient. You get money back by making your home more energy efficient, by buying a more energy efficient car. It saves you money. So that's the first thing to do. The second thing is to convert to ways of producing electricity or fuels that don't use fossil fuel. So most of the alternatives are for the production of electricity, and they're basically three ways of doing this. There are renewables like wind and solar power, and hydropower can produce large amounts of electricity without emitting any carbon dioxide or only tiny amounts of carbon dioxide. And there has been a large growth in the use of solar and wind power, although they're still fairly small. There's still a fairly small percentage of total energy use in the United States. Currently, 80% of our energy comes from fossil fuel in the United States. That other 20% comes from those renewables I just mentioned and nuclear power. So nuclear power would be the other main way of producing electricity without emitting carbon dioxide. A final possibility is to change the way we use fossil fuels. So there are ways of taking natural gas or coal and converting it into a gas or fuel like hydrogen and capturing the carbon dioxide and pumping it underground where it would stay permanently. And so there may still be ways of using fossil fuels, or we still may be able to use fossil fuels, but without emitting the carbon dioxide into the atmosphere. So efficiency first, then renewables and nuclear power, and then possibly using what's called carbon capture and sequestration to use fossil fuels without emitting carbon dioxide into the atmosphere.
So, how will global warming change our daily lifestyles?
Well, I guess I should have said that regardless of what we do to reduce our emissions of carbon dioxide, even if we improve efficiency and even if the use of renewables and nuclear grow, climate is still going to change. We're still going to have significant climate change. And that's because this carbon dioxide that we've emitted over the last 100 years is in the atmosphere, and it's going to stay in the atmosphere. And the Earth will continue to warm. And we'll see the effects of that in some of the ways I mentioned previously. You know, the winters in particular will be warmer. The summers will also be warmer. There'll be more storms. Sea level will rise in places. And we will have to adapt to those changes as best we can. For some countries that are wealthy, like the United States, it will be easier to adapt. So U.S. farmers will have to change the crops they grow to adapt to the new climate. So for example, in a place where wheat is currently grown, it may in the future, in 30 or 50 years, it may be better to grow corn. In a place that gets drier, you may no longer be able to grow crops. It may be converted to pasture land. There may be areas where water becomes more scarce because of more evaporation from a hotter climate. And so those areas, like the Southwest, will have to use water more efficiently. So those are, and in places where sea level rises to the point where towns are threatened during storms, either seawalls will have to be built to keep the ocean out, or those towns will have to be, the buildings that are near the ocean will have to be relocated farther inland so that they're not threatened by waves and ocean surge during storms.
So would there be any extremely drastic changes?
I think in the longer term, well, first I should say we don't know. The climate is very complicated. Our ability to understand it and what will happen in response to these changes is limited, where we have best guesses. But the higher the concentrations of carbon dioxide go in the atmosphere, the farther and farther we get from the climate that we understand, that human beings have experienced over the last 10,000 years. And the harder it gets to predict the changes that will occur and how it will affect humans. There could be consequences that we simply don't anticipate. So, for example, we don't know really how sensitive the ice sheets in Greenland and Antarctica are to a warming ocean. The rate of sea level rise could be much faster than we anticipate. And so sea level rise could be much greater. So to give an example here, we live near Washington, D.C., and Washington, D.C. is almost never flooded. But if sea level were to rise 3 feet, then during any severe storm, a large part of downtown Washington would be flooded, would be underwater. Water would pour into the metro system, for example, and shut down all the trains. It would pour into the basements and parking garages of federal buildings downtown. So to prevent that, we would need to build walls to keep the ocean out, or pumps to pump the water out. Those are ways that, we try to adapt to climate change. That's my phone. Sorry.
Do you need to get
No,
that
I'll
out?
just let it go.
Okay.
I'm assuming you can edit this, right?
Yeah.
That's probably one of the things you're doing
Yeah.
in the class.
So, how are the government or other organizations looking into alternate energy sources?
Well, the federal government has a large program, research program, on alternative energy sources, on wind and solar, on geothermal, taking the heat in the earth and using that for energy, on nuclear fusion, on nuclear fission, the nuclear reactors that we have now. Research programs to try to make these sources more attractive by either making them cheaper, or in the case of nuclear energy, safer, so that they can compete. They're better able to compete with fossil fuels, with coal or natural gas. So that is, I think, that holds a lot of promise, that if the alternatives, if you could make solar energy cheaper than fossil fuel energy, then people would naturally buy it. They would naturally adopt it because it would be the lowest cost. So that's one way. Another way of coping with climate change is to better adapt to climate change, to try to better forecast what the changes in climate will be, to try to anticipate those, and then make changes. Like if you're going to build a new sewage treatment plant, you don't build it where you think there will be floods in the future. You build it on higher ground. You don't build roads where you think they might be washed away in the future. And so you try to adapt to climate change, and federal and many state governments have programs to try to anticipate the changes in climate and then plan for the long term accordingly.
So how will the environment around us or wildlife be affected by global warming?
There is likely to be major changes in wildlife. Some species may be extinct as their habitat no longer exists because the trees and plants that grow in a particular location depend on the climate. And as climate shifts, as temperatures get warmer, as precipitation changes, then the kinds of trees that we have here will change. So for example, in New England, people like to see the sugar maples. They have the bright red leaves, it's very pretty. They only grow in a certain temperature range. And that temperature range will shift north. And there may, in the future, be no sugar maple trees in Vermont, for example. And all of the wildlife, the birds and animals that had adapted to live in those habitats, they will also have to shift. Or if they're unable to shift, some may become extinct. This is really hard to forecast because our ability to forecast changes in plants and animal communities is even more challenging than our ability to forecast climate change. But it is likely that there will be major, and noticeable changes in any given location in plant and animal communities. I could just say, one thing we've already observed is that pests, for example, certain pests that destroy trees can be positively affected by climate change because it's warmer in the winter. They aren't killed by frost, and so you can have more pests and more destruction of trees. Another effect is the drying of soil, and we see this in the Southwest. Because of warmer weather and more evaporation, the soil gets drier, and forest fires are more common. So the frequency of forest fires has increased quite significantly, especially in the Southwest. And of course, forest fires are very destructive, not only for the trees, but for the animals that live in those forests.
So some scientists argue that global warming isn't really caused by humans, but more of the Earth itself going through a natural cycle. So how do you feel about that?
Well, first, very few scientists believe that. I do know one or two who do, but they're in a very small minority. We do know from studying plant records, fossils, tree rings, and ocean sediments, lake sediments, ice cores, we know that climate has changed over time. But in the past, climate has changed very slowly, over thousands of years. So the changes that we're experiencing now are far more rapid than any that we can see in the past. We also have climate models that we can, computer models of climate, and we can use those to predict how climate changes naturally, these natural cycles that happened in the past. And those natural changes in the past, those natural cycles, are driven by small changes in the Earth's orbit. So the Earth's orbit around the sun is not perfectly round. It's slightly elliptical, it's slightly egg-shaped. And that shifts very slowly around the sun. The Earth also, as you know, it spins on its axis. That's, every day the Earth goes around once. But that axis wobbles a little bit. It precesses. So if you've had a top, you spin a top on a table, and the top spins, but also it wobbles a little bit as it spins, and the Earth does the same thing. And so the angle of the Earth's axis with respect to the sun also changes slowly. And these were the causes of the past natural changes in climate. So when we use our computer models, our best models of climate, they predict very well the observed changes, the changes that we've seen over the last 40 or 50 years. They predict these changes very well when we include the effect of the carbon dioxide that humans have put into the atmosphere. If we don't include that, the models don't fit the observed change very well at all. They don't fit it at all. And so there is no known natural cause of the climate change that we're seeing. And believe me, scientists have looked very hard. They've looked at, for example, changes in sunlight, the amount of light that the sun emits. They've looked at volcanoes that put dust in the atmosphere. Scientists have looked at, in addition to these changes in the Earth's orbit, everything that we can measure, and none of those would explain the changes that we're seeing, the increase in temperature. The other factor is we can see other changes in the Earth system, in addition to just the change in temperature. So, for example, we see the amount of heat in the ocean increasing. We see the sea level rising. We also see the ocean getting more acidic, more acid. All of these observed changes fit what you would expect if the cause of the climate change were the carbon dioxide that humans put in the atmosphere. None of these things can be explained in any other way.
Okay. Do you have any last thoughts?
Well, just to say, this is one of the most challenging problems that humans face, is dealing with climate change. Both reducing our use of fossil fuel, really eliminating the use of fossil fuel over the next 40 or 50 years. That's one huge challenge. And a second big challenge will be adapting, coping with the changes in climate that are going to happen, that are inevitable. Sea levels are going to keep rising to some extent, no matter what we do. But I think that humans are very resourceful. We're very clever. We can invent better solar cells and batteries and make our cars more efficient, even without drivers, as you may have heard Google is doing. And so I have a great amount of optimism and hope that using our ingenuity, we will be able to greatly reduce carbon dioxide emissions and stabilize climate.
Okay.
Thank you.
Thank you.